Hi everyone. So in this lecture we will see the working principle of the DC generator. So what is a generator? A generator is the one which is going to take mechanical power as input and provides electrical power as output. So how we can give mechanical input in general? It can be given through any prime mover like a turbine. It can be any turbine, gas or steam or water turbine, hydro turbine, anything. So, what is the main principle of operation of this DC generator? That is again Faraday's law of electromagnetic induction. So, as per this, whenever a conductor is placed in a varying magnetic field or a conductor is moved in a magnetic field, that means whenever you have a relative motion between the magnetic field as well as the conductor, whether conductor can be moved in a stationary magnetic field or a conductor can be placed stationary in a rotating magnetic field. Anything is fine. So if there is a relative change in the magnetic field with respect to the conductor, we will get an EMF. EMF is nothing but electromotive force which will be induced in the conductor that is placed in the field. So the magnitude of this induced EMF can be calculated from the EMF equation of DC generator that we will see in our further classes. And if the conductor is provided with a closed path, what happens? That means if some load is connected, then the induced current will be circulating within that path. And in the DC generator, field coils produce the electromagnetic field and the armature conductors are rotated into the field. So the electromagnetically induced EMF is generated in the armature conductors. And the direction of the induced current is generally given by the Fleming's right hand rule. So we will see what is Fleming's right hand rule. Right. So you remember this is the right hand rule and it gives you the directions for DC generator. So what is that? As per you know that as per Faraday's law of electromagnetic induction, when a conductor moves through a magnetic field, an electric current is induced in it. And Fleming's right hand rule is used to determine the direction of the induced current. So it gives you the direction of current based on the magnetic field as well as the rotation of the rotor. So but how it is? So if you see here it states that if we arrange our thumb, forefinger and middle finger of the right hand perpendicular to each other as shown in the figure, then the thumb points towards the direction of the motion of the conductor relative to the magnetic field. That means how this direction is decided? That is decided based upon the given input, that is motor or whatever is giving the mechanical output that will be input to the electrical generator. So that is given taken by the thumb finger, and the forefinger is the one which points towards the direction of the magnetic field, and the middle finger is the one which points towards the direction of the induced current. So if you know the direction of rotation as well as the direction of magnetic field, you can identify the direction of the induced current using this Fleming's right hand rule. So this is how you can get it. So that's it. And there is one important component in DC machine as we discussed in the construction of the machine, that is commutator. So it is generally made up of split ring. So why we need to use this split ring, we will discuss it again here. So as I said, the direction of the induced current changes as per Fleming's right hand rule whenever the direction of motion of the conductor changes. Fine, that you can get as per by practicing with your fingers. And let us consider an armature rotating clockwise and a conductor at the left is moving upwards, so which is shown as case 1 there in the figure. And when the armature completes a half rotation, what happens? The direction of motion of the particular conductor will be reversed with the half rotation. That means it becomes downwards now. So towards the north pole side, if you see in case 1, it is upwards, the direction of motion of the conductor is upwards. Towards the south pole, it is downwards. So hence the direction of current in every armature conductor will be alternating. But if you look at the above figure, you will know how the direction of induced current is alternating in an armature conductor. That's how as per Fleming's right hand rule. But if you use a split ring commutator, the connections of armature conductors also gets reversed whenever the current reversal occurs. So then what happens when the connections of armature conductors gets reversed? The overall current direction will be uniform. That means the direction that you get across the brushes is unidirectional. So this is how the commutator is useful for converting that alternating current direction to the unidirectional current. Right. The main logic here is that the commutator is also rotating, and whenever the current direction is changing, it changes the connections of the armature conductors so that the current reversal will takes place. That means the current reversals in other half cycle is nothing but the uniform current direction or unidirection of the overall conductor current. Fine. So now we have EMF equation of DC generator, because in case of DC generator the main output is generation of, because in generator electrical output is there, which is electromotive force, that is voltage. So generation of voltage is nothing but generation of electrical output. So we need to look at the derivation of this, and in order to do this we need to perform two actions. First one is to determine the induced EMF of the one conductor, then induced EMF of the overall generator. So we will see how it is done. So there are two different methods for deriving this, but this is an easy method, and for a simple understanding for basic electrical engineering course we can proceed with this. So in order to get induced EMF of one conductor, you assume that for one revolution of the conductor, the flux produced by one pole is pi. So pi units are in Webers. And if you have p number of poles in the generator, what will be the total flux produced by all the poles for one revolution? That is pi into p. So that you can see here. Then we will see the time taken to complete one revolution. So if you assume that capital N is time taken for one revolution, that is RPM. So revolutions per minute is capital N. If that is the case, what is the time taken to complete one revolution? It will be 60 by N per second. So we need in general per second in order to get any expression. So now we will see EMF. So as per Faraday's law, we all know that EMF is, so as per Faraday's law, what is the magnitude of induced EMF? It is rate of change of flux with respect to time. So here we are neglecting the negative sign, and if you neglect that, that means we are considering only magnitude, and that will be total flux divided by the time taken for producing that flux. So from the above, we can say that the total flux is pi into P, and the time taken for one revolution is 60 by N. So if you substitute all these things here, you will get induced EMF is equal to pi P N by 60. Right. Now this is for one conductor. We will see what will be the induced EMF for overall DC generator. So because we will have several conductors in DC generator, and those conductors are also placed in different number of parallel paths. So if you take the voltage across one parallel path, it will be done, because all parallel paths voltages will be equal because they are connected in parallel. So several conductors are there which are connected in one parallel path. So we need to get that overall voltage. So in order to get that, if you see the Z is the total number of conductors in one parallel path in entire generator, and if you take A as number of parallel paths, then Z by A will be the number of conductors connected in series in one parallel path, right? So accordingly, we can get the induced EMF of total generator, which is same as EMF of one conductor multiplied with the number of conductors connected in series in one parallel path. That is very important here. That means what is the EMF of one conductor? That is pi p n by 60, and the number of conductors connected in series in one parallel path are equal to Z by A. So the product of these two will be giving the total EMF of the generator. Fine. This is all about the induced EMF of DC generator. This concludes the principle of operation of DC generator. Thank you.